When dealing with organic compounds containing two or more functional groups, it is often necessary to protect one functional group while carrying out a reaction at another functional group. Let's say that we want to synthesize 4-heptine 1-ol from 4-pentyne 1-ol. When we look into this reaction, we can see that there are two extra carbons in the product than what we have in the starting material. You may think that we can take advantage of our acetylide ion formation by reacting it with NaNH2, which can abstract this hydrogen and it can form the new carbon-carbon single bond. But in this particular compound, you can see that there are two acidic hydrogens. We have the hydrogen that is connected to oxygen and a hydrogen that is connected to an sp carbon, right? Between these two hydrogens, which one will be abstracted when it is reacted with NaNH2? So for that, let's take a look into the pK values. The pK value for this OH hydrogen is going to be about 16 to 18, right? And for this hydrogen that is connected to sp carbon, it's going to be about 25, right? So when you react it with NaNH2, it is not this hydrogen that will be deprotonated, but it will be this hydrogen that will be abstracted, resulting in the alkoxide anion. So the product that you will be getting from this reaction is going to look like this, right? But this is not what we want, right? We need to put those two extra carbons in there to form the compound that we want. Okay, then how are we going to proceed with this reaction? The best way to carry out the synthesis is to protect the OH group to prevent its reaction with sodium amide. A good protecting group is easily added to the sensitive functional group and it is resistant to the reagents used to transform the unprotected functional group or groups. And then finally, it is easily removed to regenerate the original functional group. So what we'll be doing here is first we'll protect the OH group. And then we will carry out a synthesis where we form the new carbon-carbon bond with two extra carbons. And then we will do the deprotection of the OH group. Okay. Now the best way to protect an alcohol is to convert that into silyl ether, where we react it with trimethylsilyl chloride in the presence of a base, such as triethylamine. Okay. So once we get the silyl ether, we're then going to react it with NaNH2 to abstract the hydrogen, to abstract the acetylenic hydrogen, and then react it with ethyl bromide since we need two carbons here. Okay. So once this hydrogen will be abstracted, it's going to form the acetylide ion. And this acetylide ion is going to make a nucleophilic attack on this carbon. So we can form a carbon-carbon single bond between this carbon and this carbon from the alkyl halide. Here is the new carbon-carbon single bond that's formed. Now the final step is deep protection of this silyl group, right? For which we'll be using tetrabutyl ammonium fluoride, and it's going to cleave the bond between oxygen and silicon, thereby forming the alcohol that we want. This is how we protect and deprotect the alcohol groups.